Right now, somewhere in Switzerland, a watchmaker is adjusting a gear so small it weighs less than a grain of rice. Move it by just a few microns, and an entire watch can lose its accuracy. That's the level of precision hidden inside every Rolex. A precision so extreme that hundreds of tiny components must work together in perfect harmony. One microscopic speck of dust, one gear slightly out of alignment, one drop of lubricant in the wrong place. Any of them could affect the movement that keeps perfect time for decades. But that raises an obvious question. Why? Why can one mechanical watch cost more than a brand new car, when cheaper watches can also tell the time? The answer isn't a logo, it isn't gold, and it isn't marketing, it's engineering. Today, we're going inside one of the world's most famous watch manufacturers to discover how raw metal becomes one of the most recognizable timepieces ever made. From the first digital design, to microscopic gears, to extreme pressure tests. This is how a Rolex is really made. Before a single piece of steel is, every Rolex begins as an idea. Designers, engineers, and watch specialists work together long before production ever starts. Every curve of the case, every hand on the dial, every index, every surface, every reflection. Nothing is left to chance, because a luxury watch isn't judged only by its appearance. It must also feel perfectly balanced on the wrist, be instantly readable, remain comfortable after hours of wear, and continue working flawlessly for decades. Once the concept is approved, the engineering begins. Using advanced three-dimensional computer models, engineers simulate every component before it's ever manufactured. They analyze dimensions measured in fractions of a millimeter, stress points, material expansion, assembly tolerances, even the way light reflects across polished surfaces. Sometimes, a tiny design change affecting just one component forces engineers to redesign dozens of surrounding parts, because inside a mechanical watch, everything depends on everything else. Only after months of development do the first physical prototypes appear. These aren't built for customers. They're built to answer questions. Does the bracelet move naturally? Is the crown comfortable to operate? Can the movement fit inside the case with perfect tolerances? Will every component survive years of daily use? Some prototypes never leave the laboratory. Others are completely redesigned before production even begins. Because once manufacturing starts, there is almost no room for compromise. And everything begins with one thing: metal. Not ordinary steel, but one of the most corrosion-resistant alloys used anywhere in the watch industry. Because before Rolex builds a movement, it builds the material that will protect it. Long before a Rolex becomes a watch, it begins as raw metal. But not just any metal. Rolex manufactures many of its most important components using materials specifically chosen to survive decades of daily use. One of the most famous is oyster steel, a premium stainless steel belonging to the 904L family, an alloy more commonly found in the aerospace, chemical, and marine industries than in watchmaking. Why? Because it offers exceptional resistance to corrosion. Salt water, humidity, sweat, even years of exposure to harsh environments leave it remarkably unchanged. And unlike conventional stainless steel, it also takes an extraordinary polish, allowing every surface to reflect light with incredible clarity. For its precious metal watches, Rolex goes even further. Instead of purchasing finished gold from suppliers, the company operates its own foundry. Inside these highly controlled facilities, pure gold is transformed into proprietary alloys: yellow gold, white gold, and one of the brand's most distinctive materials, Evaros gold, an exclusive 18-karat rose gold alloy developed to preserve its warm color over decades. Most rose gold slowly fades as the copper inside oxidizes. Evaros was engineered specifically to resist that process. Even after years of wear, Its color remains remarkably stable. Certain professional models introduce even more specialized materials. Grade 5 titanium, known by Rolex as RLX titanium. It's significantly lighter than steel, yet incredibly strong. Perfect for watches designed to withstand extreme conditions. Bezels are often crafted from cerachrome, a ceramic material so hard it's highly resistant to scratches and fading. Even prolonged exposure to ultraviolet light won't alter its color. The crystal protecting the dial isn't ordinary glass either. It's synthetic sapphire, one of the hardest transparent materials ever used in consumer products. Only diamond is significantly harder, but choosing premium materials is only the beginning. Every batch undergoes rigorous inspection before production even starts. Its chemical composition, its purity, its mechanical properties, everything is verified, because even the finest engineering cannot compensate for imperfect raw materials. If the metal isn't flawless, nothing built from it ever will be. Once approved, the transformation begins. Massive blocks of steel and precious metals enter highly automated computer numerical control machining centers. Computer-controlled cutting tools remove material with astonishing precision, tiny amounts, again and again, until rough blocks slowly become recognizable watch components. A watch case, a bezel, a crown, each surface measured in microns, far thinner than a human hair. Even after machining, the parts are far from finished. They pass through multiple stages of polishing and satin finishing. Some surfaces become mirror-like, others receive a soft brush texture. Every between finishes must be perfectly sharp. A single polishing mistake could ruin an entire component. Many finishing operations are still performed by highly skilled technicians, not because machines aren't capable, but because the human eye can detect imperfections that even sophisticated instruments sometimes miss. When the exterior components finally meet Rolex standards, attention towards something far smaller. Hundreds of miniature parts, each one responsible for keeping perfect time. Because the real masterpiece of a Rolex is hidden where almost nobody ever looks, inside its movement. If the case protects the watch, the movement gives it life. This is where a Rolex stops being a collection of beautifully machined parts and becomes a precision instrument. Hidden inside every mechanical Rolex are hundreds of individual components working together with astonishing accuracy. Gears, pinions, springs, levers, jewels, each one performing a single task. Together, they measure time with incredible consistency. Everything begins with the main plate, a rigid metal foundation that supports the entire movement. One by one, watchmakers install bridges, wheels, and tiny gear trains. Every component must fit perfectly, not almost perfectly. Some parts are so small, they're barely visible to the naked eye. A misplaced gear by only a few microns can affect the performance of the entire movement. That's why assembly takes place in an environment where dust, humidity, and temperature are carefully controlled. Because at this scale, even the air matters. At the center of the movement sits the mainspring. Think of it as the watch's battery, except instead of storing electricity, it stores mechanical energy. As the spring slowly unwinds, it releases that energy through a precisely controlled chain of gears. Power flows from one wheel to the next, until it finally reaches the escapement, the tiny mechanism responsible for dividing time into perfectly measured intervals. Without it, the spring would release all of its energy in seconds. The watch would simply stop. Keeping the mainspring wound is the job of one of Rolex's greatest inventions, the perpetual rotor, a semicircular weight that moves freely with every motion of the wearer's wrist. Walk, reach for a door, raise your arm. Every natural movement causes the rotor to spin. That movement automatically rewinds the mainspring. As long as the watch is worn regularly, it never needs manual winding. A remarkably simple idea, but one that transformed mechanical watchmaking forever. Inside the movement, friction is the enemy. Tiny gears rotate thousands of times every day. Without protection, they would wear out surprisingly quickly. That's why Rolex uses synthetic rubies, not because they look beautiful. In fact, most owners never even see them. They serve a far more practical purpose. These laboratory-grown jewels act as ultra-hard bearings, supporting rotating shafts while dramatically reducing friction and wear. A typical Rolex movement contains dozens of them, each placed exactly where the mechanism needs them most. Lubrication is equally critical, but here's something surprising. Adding too much oil can be just as harmful as adding too little. Using microscopic applicators, specialists deposit incredibly small droplets onto specific contact points, sometimes amounts almost impossible to see without magnification. Too much lubricant spreads through the movement, too little increases wear. Every drop must be placed with extraordinary precision. Then comes one of the most delicate components in the entire watch, the balance wheel. Together with its hairspring, it acts like the heartbeat of the movement, swinging back and forth several times every second. Its rhythm determines the accuracy of the entire watch. Rolex developed its own parachrom hairspring to improve this performance. Made from a special alloy, it's highly resistant to magnetic fields, temperature changes, and everyday shocks, conditions that can easily affect ordinary mechanical watches. Finally, power reaches the escape wheel. The balance begins to oscillate, the gears start turning, and for the very first time, the movement comes alive. A quiet, almost hypnotic rhythm. Tick after tick after tick. Hundreds of components working together with extraordinary precision. But even now, the watch is still incomplete because the movement still needs a face, a body, and the final assembly that transforms a mechanical mechanism into one of the world's most recognizable watches. By now, every component has been manufactured, inspected, cleaned, and approved. But the most demanding stage of the entire process is only just beginning. Assembly. This is where hundreds of microscopic parts must come together with absolute precision. A single fingerprint, a single grain of dust, or one component installed a fraction of a millimeter out of position could affect the performance of the entire watch. That's why assembly takes place under strictly controlled conditions. Every workstation is designed to minimize contamination. Every tool is chosen for a specific task, and every movement is deliberate. Nothing is rushed. The process begins by carefully placing the completed movement inside the watch case. It sounds simple. It isn't. The movement must sit perfectly centered, perfectly aligned with the winding crown, perfectly secured without introducing any stress that could affect its accuracy. Once positioned, the dial is installed. This is the part every owner sees. Yet even here, precision matters more than appearance. Every index must line up perfectly. Every logo, every printed marking, everything must be perfectly centered. Even a tiny misalignment, invisible to most people, would immediately fail inspection. Next come the hands, the hour hand, the minute hand, and finally, the seconds hand. Each one is pressed onto its shaft using specialized tools. The distance between them is incredibly small, too high, and the hands may touch the crystal, too low, and they may rub against each other. Either mistake would stop the movement. Every clearance is measured, every rotation is checked. Only when all three hands move freely can assembly continue. Now the movement finally receives its armor. The sapphire crystal is fitted, precision gaskets are installed, the screw-down case back is tightened, and finally, the famous oyster crown is secured. This is far more than a winding crown. It's one of the reasons Rolex became famous. Together with the case and crystal, it forms a sealed system designed to keep water, dust, and moisture away from the movement. even after years of daily use. The bracelet is assembled separately before being attached to the case. Each link is inspected individually. The articulation must feel perfectly smooth, no excessive play, no stiffness. Every polished and brushed surface must align seamlessly from one link to the next. The clasp is opened and closed repeatedly. Locking mechanisms are checked. Tiny adjustments are verified. Because the bracelet is not just an accessory, it is part of the engineering. It must feel as precise as the movement itself. Now, for the first time, the watch looks complete. But appearances mean nothing. Not yet. Because before any Rolex leaves the factory, it must survive a series of tests designed to simulate years of real-world use. Extreme pressure, power reserve, shock, magnetism, accuracy. Only then can it truly earn the name printed on its dial. At this point, the watch looks finished. Its polished surfaces reflect the light perfectly. The bracelet feels flawless. The hands move with effortless precision. To almost anyone, it would already be ready to wear. But inside the factory, this is where the real challenge begins. Because every Rolex must now prove that it deserves to leave the building. The first test is accuracy. Even the smallest variation can become noticeable over months or years of use. To prevent that, each watch is monitored in multiple positions: face up, face down, crown up, crown down, sideways. Gravity affects every mechanical movement differently. A watch that keeps perfect time lying flat may behave differently when worn on the wrist. Technicians measure these tiny variations and adjust the movement until it performs consistently in every position. Next comes the power reserve. The watch is fully wound, then left running without interruption. Hour after hour, its performance is carefully monitored. The movement must continue operating within its specified reserve while maintaining stable accuracy from the first hour to the last. Because precision means very little if it disappears after a day. Then comes one of Rolex's most famous characteristics: water resistance. The completed watch is placed inside specialized testing equipment that simulates enormous water pressure. Without ever entering water, sensitive instruments detect microscopic case deformation and tiny leaks impossible to see with the naked eye. Professional diving models face even harsher conditions. Pressure levels exceed the depth engraved on the dial if the case, crystal, crown, or seals fail, even slightly. The watch is rejected immediately. But water isn't the only enemy. Modern life surrounds us with invisible forces: speakers, computers, airport scanners, electronic devices. Many of them generate magnetic fields capable of affecting traditional mechanical watches. That's why movements are also tested for magnetic resistance. Along with rapid temperature changes, repeated shocks, and thousands of simulated wrist movements, the goal isn't simply to prove the watch works today. It's to make sure it continues working years from now. Finally, every completed Rolex undergoes the brand's own internal certification process. After passing the official Swiss chronometer tests, the fully assembled watch is tested once again. This final inspection measures the performance of the entire watch, not just the movement. Only watches that meet Rolex's own extremely strict accuracy standards receive the title Superlative Chronometer. It's the company's final promise that every component, every adjustment, and every hour of work has achieved the level of precision expected from one of the world's most recognizable watches. So, after hundreds of components, months of engineering, thousands of inspections, and countless precision tests, one question still remains. Why does all of this make a Rolex worth what it costs? The answer has very little to do with gold, and everything to do with perfection. After seeing the entire process, it's tempting to think you're paying for steel, or gold, or sapphire crystal. But that's only a small part of the story. The true value of a Rolex isn't hidden in its materials. It's hidden in its precision. Every component is manufactured to incredibly tight tolerances. Every surface is inspected. Every movement is assembled by highly trained specialists. Every completed watch is tested again and again until it meets standards that leave almost no room for error. Most manufacturers rely heavily on sampling. Rolex inspects virtually every stage of production, not because it has to, because that's the philosophy the company has followed for more than 100 years. And perhaps that's what makes mechanical watchmaking so fascinating. Inside a watch barely 4 centimeters across, hundreds of tiny components work together without batteries, without software, without electronics, powered only by springs, gears, gravity, and extraordinary engineering. A miniature machine designed to keep time for decades, sometimes for generations. That's why many Rolex watches are never truly replaced. They're serviced, adjusted, passed from parents to children, from one generation to the next. Long after the original owner is gone, the movement can still be ticking, still measuring time, exactly as it was designed to do. Very few everyday objects are built with that kind of lifespan in mind. So, does a Rolex cost thousands of dollars because it's made from expensive materials? Partly, because it's assembled by skilled watchmakers, also. But above all, it costs what it does because every stage of its creation is built around one idea: precision without compromise. From the first computer model to the final accuracy test, nothing is left to chance. And that's what you're really buying. Not just a watch, but decades of engineering, condensed into something that fits on your wrist. If you enjoyed discovering what really happens inside one of the world's most famous watch factories, you're in the right place. Here on Source Code, we go beyond the finished product to uncover the engineering, technology, and craftsmanship hidden behind the objects we use every day. If you don't want to miss the next journey, subscribe, turn on notifications, and we'll see you in the next episode of Source Code.